let's begin today's journey. So before we do that, let's take a look at my to-do list, all right? So these are the problems I received in the comments, and I'm going to finish it one by one in this order, all right? So make sure I get your problem here. If not, just comment on my most recent videos, all right? So let's begin the problem E here. As always, we are going to introduce this problem by explaining the example here, all right? So here is the example. In the input, we have a n here. So it means the number of nodes in a tree, right? And the following several lines are the edges in the tree. For this particular case, we have a tree like this, right? So there is an edge between 1 and 2. So it's this one, right? And one edge between 1 and 3 is this one. 3 and 4, this one. 3 and 5, this one. 2 and 6, this one, right? So this is a tree. And then we are going to find out n segments. And the segments will satisfy some particular conditions, right? So these are the segments in the output, right? So we have 9, 12. So from 9 to 12, this segment, right? 7 to 10, this segment, right? So these are the segments in the output. And as we can see, if segment 1 and segment 2 has some overlaps like this one, right? It means there is an edge between node 1 and node 2, right? This overlay corresponds to this edge, right? And there is an overlay between 1 and 3, these two segments, right? This overlay. So these two nodes also has an edge between them in the tree, right? And the same way, segment 1 will not have any overlay between other segments. For example, between 2, actually between 2 there is an overlay, so there is an edge. But between 4, there is no overlay, right? No overlay between these two segments. So there is no edge between these two nodes, right? And segment 2 is completely covered by segment 3. So it means there is no edge between 2 and 3, right? There is no edge here, right? So only if two segments has overlay and they don't completely cover each other, they will have edges between them in the tree, right? For example, these two guys, 3 and 4, right? 3 and 4 has an edge, right? So we are going to find out a set of segments that satisfy this condition. So the segments can map to the nodes in the tree, right? So how can we construct this kind of set of segments? So we are going to do it in this way. First, we are going to start from the root node, right? So we start from the leftmost point here. So at this point, we draw a starting point at the first point. Then this segment 1, should have an overlay between segment 2 and segment 3, right? So now we are going to draw a starting point of segment 2 and segment 3 at point 2 and point 3 separately, right? And then there is no segment overlay with segment 1 anymore, right? So segment 1 should close here, right? So this is our segment 1. This is the ending point. So in this way, we can be sure that segment 1 only overlays with segment 2 and segment 3, right? And let's keep moving. Now we are going to find the segments that are connected with segment 3 here, because 3 is last contact with segment 1, right? So we find the nodes that connect with segment 3 here. So as we can see, we can find a segment 4, right? So we draw a starting point of segment 4 here. And then we got segment 5, right? And now all of the nodes that are connected with the segment with 3 are already visited, so we can close segment 3 now, right? So we draw a close point here and close the segment 3, right? And as we can see, segment 5 already closed, right? There is no more node connected with the node 5, so we can close segment 5 here. So let's close it. Draw an ending point here and close it. And so as 4, we can close 4 now, because 4 does not have any more connecting points, connecting nodes, I mean. So we can close 4 here. So we we draw the starting point of 4 first, and draw the ending point of 5 first. So in this way, we can make sure the nodes on the right, the segment 5 is completely covered by nodes on the left, segment 4. So in this way, we can be sure that this segment covers this segment, and so that 4 and 5 doesn't connected with any edge, right? So in this way, we can make sure of it, right? So we visit all the subnodes of node 3. Now we come back to node 2, segment 2, right? We can close segment 2 now. So we draw an ending point here and close segment 2. And now segment 2, actually we can't close segment 2 right now, because there is still a node 6 here. So we need to draw the starting point of 6, and then we can be sure that all of the nodes are connected to node 2 already visited, so we can close segment 2 now, right? So we draw an ending point here and close segment 2. And now we can close 6, right? So we draw an ending point here and close it. So in this way, we used all of this space from 1 to 12, right? And we get six segments. And for the first segment, it overlays with 2 and 3, just as the problem needs, right? And the segment 2 overlay with uh, segment 6, right? Cool. And segment 2 completely covers segment 3 and segment 4, segment 5. So they don't have any edges between these nodes, right? So this edges does not exist, right? So in this way, we can make the set of segments, right? So that's how we construct the segments here. So let's see the code. So here is the code. First, we are going to read in n and all the edges, right? And then we mark the point we are going to assign to is the current, right? So current we are going to either assign a starting point or assign an ending point to this location, right? And this guy is the starting point of segment 1, is starting from 1, right? And then we are going to start from node 1, right? And we are going to do a deep first search, right? And for the node 1, we are going to write the starting point of its children first, right? We are going to iterate all of its children, and we make sure that we don't go back to its parent, right? For example, this node is P, and this node is last, right? This node last is P's parent. So this part is just to make sure that we don't go back to its parent, right? So this part is where we add a starting point for all of its children from left to right, right? And then we're going to, after we visit all its children, we're going to add an ending point for the current segment, right? And then we are going to draw the children segments recursively and reversely, right? From right to left, to draw all of the children segments, right? And we are doing this recursively. And in the end, we are going to output all of the segments, right? One by one. So I guess that's it. To solve this problem, we need to um, have a good understanding of DFS, right? So how to solve a problem recursively, right? So I guess that's it for today. Thank you for watching. See you next time.